of such luminaries, sir. Thank you indeed from the bottom of my heart. I should thank Dr. Priyanshi for giving me this opportunity. And today I would like to share in the next hour or so some of the disruptive technologies. So this is actually a faculty development program. So you must have understood by now the focus and the power of AI, but something how AI can be applied to real-time problems, to problems of national security, to improve the operations, and that is where I would like to touch upon. Uh, I will request permission to start, and this is my first slide. So we are going to talk about AI, the disruptive technologies, particularly in relation to naval operations. And the scope of my presentation today is I would like to give a brief background, because I think I'm talking to young students and I'm talking to very illustrious professors. Normally, there are a lot of consultancy work which comes to the academia, but you only get to know a part of it, because we normally in the services or in the defense forces, we have this sense of a lot of secretism. So that is why we don't divulge more information. But today I would like to give you, from a lot of open sources domain, a complete understanding of what happens in naval operations, right from the nation's topmost office, like the PMO's office, to a fleet ship, and how this we are transforming into a digital service. So I would like to first start with the evolution of the naval warfare. Then I would like to see why it is so important to get digital. What are the recent trends? What is driving our thought process, our doctrine, our paradigm shift? And if we are now convinced as the Navy, as a nation, that we have to go digital, then how do we go about it? So there's a systems approach for digital transformation, and I would like to bring about some of the aspects there. And once you are digital, that means the data is available to you, and the data in all organization, like a pan organization like Navy, is a huge amount of voluminous data, which we call it the big data. We are aware of this. So from this big data analytics, how do we apply algorithms to make it smart, make it effective, make it meaningful for us? And I would like to last of my small 2-3 slides I have, primarily trying to motivate some of the students, some of the faculty members, to show you what are the opportunities available in some of the research and development projects, where under this Atmanirbhar scheme, there are a lot of schemes where they are promoting defense research, because this is something very niche. And second thing is, once if you see right from the internet, which was erstwhile a DAPA project, everything is the topmost technology comes first, possibly to the national security and the defense, and then the offshoot comes to the commercial industry. So if we put our hands into it, or if any one of us is interested in putting our hands into it, so we can partner, we can help you, and we can make you understand. So the body of knowledge stays with academia, but this application and how it can integrate to our system can be a great value which we can add on, sir. So first thing, I start with the concept of what is the naval warfare and how we have graduated. So this is an open domain document which says ensuring secure seas, Indian maritime security objective. This is what is the Indian Navy's logo. These are the frontline fleet ships. So our maritime doctrine, what is a maritime? Maritime means at sea. The water which are beyond our land, are driven top down, right from the national values and the national aim. That national interest is that we should be self-reliant. No one should be able to do a blockade to us. When I say a blockade, means it should not happen that our ports, our ships, our commercial ships cannot come in. Our national security objectives should be met. We should not have another 2611 like incident when it happened in Bombay, and that drives our national security policy and our national strategy. So when it comes to the strategy, this is where the Navy comes into play. So what I want to bring about, this is from the top down 30,000 feet approach. The top till this block is what happens at possibly the PMO, the cabinet. It's a political will. But once it comes down to the national strategy, so Navy is given a task. And from here starts the naval domain. The naval domain means the uniform domain, the ships, the assets which you see. And it is not that we're working alone. We definitely are working today in a joint military strategy where we have got Army, Navy, Air Force, Coast Guard, police services, intelligence services, Ministry of Home Affairs. There are, because there is a footprint today. If you see, terrorism knows no boundary. When Kasab came, he came just like from the sea. So obviously it was a failure of the naval intelligence, of the Coast Guard intelligence, of the naval action plan. But when he came inside, what he did, during the 2611, it actually was a part of the police activity. So there is a big amount of correlation which happens, and this is where a lot of work can be done in artificial intelligence, because there are pockets of information, silos of information, which is not concluding into a comprehensive operational picture. And lastly, we have strategies where we see how, if there is a threat, how do we break down the threat, how the threat has to be handled, and this is the national value what we get. So what I can bring down to the Navy's objective today, very quickly I will go down to this slide, so that the context is available to my listeners today. So first, the India's maritime security is to safeguard the nation's maritime interest at all times. What are the maritime interests? Basically, the first maritime interest, we should not get into a war. We are a non-aligned. We are always having a punch shield. We are driven by our, external policy affairs. But should there be a need, India has to use force. We will use force. We should use the maritime military application in a manner that enables early termination of contract on terms favorable to India. That means we have to make a very aggressive posture. So before someone comes and attacks us, or before someone comes and fires a missile at us, he should be very well aware. He should be very well done his due diligence, that what could be the repercussions. We should shape a favorable and positive maritime environment. By this we mean there should be a lot of cooperation. There are basic trade should not be hampered. Our energy security, food security. Even today, if you see, Navy was deployed extensively, and as I talk to you, there are 5 naval ships delivering oxygen cylinders to Indonesia, Vietnam, and all these countries. And when time came about 3 months back, when we were in the second wave, a lot of naval ships got a lot of naval oxygen cylinders from many of the countries abroad. And if you recollect, some years back, there was a blockade in Yemen. There was civil war in Yemen. There were Indians who were actually stuck. So Navy went there and got those people all the way from Yemen and many other countries. Lastly, and rather, one more very important part is the Indian coastal security and offshore assets. Whatever offshore assets, Bombay High, wherever we are getting a petroleum, that is our energy security. And just for the knowledge of the students here, 200 kilometers from the Indian land coast is basically the India economic exclusive economic zone, which belongs to us. So someone has to guard that, safeguard that. And that is where the Indian Navy comes into play. And lastly, to develop a requirement maritime force levels. When I say force level, obviously it's a resource allocation problem. You have got some threat perceptions and you know how to neutralize that threat. When I say neutralize, means there can be an incoming aircraft coming. To neutralize that, how we have to maintain our force levels. So based upon this, these are the objectives which come out. So when we have got something like a military objectives, we got a diplomatic objectives, and we got a constabulary. Constabulary means basically policing job. So basically we have to deterrent. So these are all written down in 3 levels. So I will not go much into these doctrines, but what are the major causes of concern? Now I would like to correlate some of the recent incidents which you all must have noticed. So we have got a lot of these. What you saw in the yellow are basically called as the sea lanes of communication, or the international shipping lines. So for example, if some ship is going to come from Cape of Good Hope to towards the Sumatra Islands or Singapore, it follows this particular path. So the safety of these entire lines, what you see, is the responsibility of all the neighboring countries of the Indian Ocean region, and Indian Navy is also a prime region for it, is one of the prime agents for it. We provide ships. So we are, as I want to bring out in this slide, this is ever given, the ship which actually blocked Suez Canal, and it blocked Suez Canal to the extent that there were billions of dollars which were lost in business in the last 7 or 8 days when it was blocked. So this is where our perception, this is nothing. What happened here is called as a threat perception. Why it is a threat? It is a threat because it threatens the India's energy security. It threatens India's maritime trade needs. It threatens India's maritime, export and import policies. So these are the basic choke points. Some of them I will just read out, like Cape of Good Hope. This one. These are basic choke points which India has to safeguard. The Navy has to safeguard, and we have to ensure the availability of this to all across board. So what is next? What is the conflict? What is a conflict? So why do we call that India has to do well in the conflict? We have to have a posture of deterrence. So conflict today is not something which is very well defined war. So as I speak to you, this year also happens to be the Swarnim Vijay Jayanti for the 1971 war. So today we have finished about 50 years of a full-fledged war with Pakistan, with the liberation of Bangladesh. But the war is not going to be the same now. It is going to be local. It is going to be asymmetric. When I say asymmetric, for a short period of time, aggressive, but localized to a local field. Localized, like Afghanistan, if you see, it was a localized, takeover. So it is not going to be a country coming up another against another country. So that is what is not likely to happen. So we have got our spectrum of conflict, revolves around something like violent conflict, which can be an external conflict, which can be a full-fledged combat, or it can be, it can escalate. It can escalate. It may not, but it can escalate to a nuclear war, which is basically now a tactical or theater war, we call it. It can also be something like a peacekeeping enforcement, that we are forced tomorrow, like, if you recollect, in 1987 India sent its forces to Sri Lanka and for the peacekeeping mission. It can be a political confrontation, like we had in Galwan, in the Galwan Valley, where the Chinese came about last year in June. They came step by step, inching towards Indian, land. So that was like a political confliction. Same thing happens. Same thing happens at sea. Internal conflict, we all understand. There can be terrorism, there can be a guerrilla warfare, and there could be a civil war, there could be subversion. So these are the total spectrum of conflict. And what happens in a conflict? So what happens in a conflict? Basically, the whole country's information mechanism is activated, and it's not activated only during war. It is activated on a daily basis, on a daily, I would say, on an hourly basis. So what importance is the information grid? The very important is the information grid. So what are the information grid? Where the Navy is sourcing information. So if you see, for the coastal security, these are the people who are involved. So we have to get information from all of them. They have their own protocols. So this is the Ministry of Defense. Then you've got Ministry of Petroleum and Natural Gas, Ministry of Finance, where we are trying to find the funding. And that what happens when you are funding a militant organization? He's buying arms, and what does he do? He comes and delivers arms. He has to send it through a consignment, through a ship, or the Purulia case, through an airdrop. So this is where we talk, where we find culprits. We want to see if there is we need to get information if there is a massive inflow of cash in some particular accounts. Then we also have the port trust. We have the Ministry of Shipping, very important, because it's the commercial shipping which we are also giving a lot of coverage. We have the fisheries, the DG hydrocarbon, which is basically looking after all the petroleum and all the energy securities of the country. And finally, the police, the Ministry of Home Affairs, where all the intelligence, the RAW, the NTRO, all of them work. So this is the framework where the Indian Navy is working. So how it executes is through these type of a network of sensors, and that is where, because the domain of this network or domain of the sensors are quite disparate, there are variations, and that is where today's technology of artificial intelligence and data mining can help us to clearly give a picture. So what happens here? If you see, this is in Gurgaon, and we have this, all the entire merchant traffic which is happening in this area, in the IOR area. India is a leader in this, and we are providing this information to us as well as to our friendly nations, so that collectively, it's a collective responsibility that we are able to curb the maritime terrorism. So then there are other centers where we work, and if you see what happens to this at the end of it, this is how our country is organized today. Our country is organized between from a strategic point of view, this is the strategic point which tells us an information, and now on this information we have to act. When we have to act, that means there is an area of responsibility, and that area of responsibility across the country is divided like this. So we have got, what you see in the reds are the Air Force unit, Air Force commands. This is a joint command where we have got Andaman Nicobar, and Navy particularly has got three major commands: the Western Naval Command, the Southern Naval Command, and the Eastern Naval Command. There are about 7 commands of the Army and about 5 of the Air Force. So this is what is today. But what we are graduating, if you see with the, if you follow up the news, so we have now a CDS, the Chief of Defense Services, and the MOD is today looking at a theater command, So it says, let us collate, let us pool, let us join information, let us join the action plan, let us join our standard operating procedures, and start working only on 3 ways. Like we have an Eastern theater, whether it is, the war comes or the threat comes from any of the domain, the air, the water, the underwater, space, or it could be land. It should be the Eastern Theater Command which should be able to handle it. Then we have got the Southern Command and the Western Command. And to top of it, should there be a reason for us to take the ultimate step, we have a Strategic Force Command. This comes directly under the Cabinet Committee on Security and the PMO, where we are all the nuclear assets. The nuclear assets may be with the Army unit, maybe with the Air Force unit, maybe with a ship or a naval ship. But the command and control, that means the launch of the vehicle, where it is launched, is controlled in a separate way in the strategic command, which is directly under the PMO. So this is what I am talking to you is all available on the net, and that is where there is nothing much to worry about. I'm not divulging any information. So what are the Navy's strategic objectives then? We are talking about indigenization and self-reliance and self-sufficiency. This is very important. If we keep buying, we are the largest importer of machines today, of firearms, weapons, and we are giving out our foreign exchange. And to curb that, the present government and the present MOD has taken a lot of steps, particularly towards indigenization. So I must appraise this audience. There are 108 such critical technologies, critical equipment, which the government has taken a stand that let us not import. And this happened last year after the Chinese aggression. So we are developing an ecosystem where we can help our industries, we can help our startups, we can help our SMEs to integrate and give us quality product, because we believe thoroughly in self-reliance and self-sufficiency. We are looking at standardization and modularity. When I say standardization, means the interfaces. When I say interface, I will just show you how it interfaces is there. We are looking at a complete maritime domain awareness. When I say maritime domain, iska matlab ye hota hai whether a threat is coming from sea, whether a threat is coming from land, air, but it is coming it needs an action by the Navy. It needs an action by the Navy, so we should be fully aware, and we should be networked. Then that gives us to the next point, that we should be network-centric operations. We should enhance our reach and sustainability. When I say enhance our reach, that means we should be looking for global bases. We should be looking, because why? A ship needs fuel. You cannot deny it. A ship needs ammunition. There will be failures. There will be supplies. How does a ship get? So we have to have, with our Ministry of External Affairs, we have to have strategic points, strategic partners who can come and operate, or where we can go and operate. Very important is power projection and sea control, force protection. Should there be any merchant marine which is having an Indian flag, it should always, or it can be a friendly neighbor, it should always be protected by us. We should be ready for joint operations. Special forces are basically the commandos. Then the force maintenance. Our ships are bound to have failures, because we are running the ships for about 330 days at sea out of 365 days. So obviously, a man fails, a machine will also fail. So that is what we have to take care, and our infrastructure and logistics has to be seamless, and we have to adopt the new evolving technology. So this is the major spectrum of our work. So I started, the first point was our indigenous effort, and the last point was an ability to adapt and accept the evolving technologies. So what outcome it comes at this level? So we, again, gentlemen and ladies, I'm talking about a situation of strategic intent. So this is where we would like to have a global picture of India. what you see here, possibly there is a threat evolving, so we should be able to isolate these areas. There possibly is a threat. Wherever there is a orange one, there is likelihood of a threat. The red one is a very critical action. So such pockets of areas we need to identify, and we need to act on it. This is the starting point, this is the strategic point, and this comes through a lot of information. And not only information, lot of data is coming. That data has to be processed using AI algorithms to make into meaningful information. So the next spectrum of the naval operations, I would like to see how. So that was that what I spoke just now was the strategic level. Now I'm coming to operationally. How do we work? How does the Navy work? And this is what was the Navy before, and this is what would possibly be the Navy, in a few years' time. And fully, it is this transition is already taking place. Now, what was this? You have to understand here. If you see, we had a national grid of sensors, we had some distributed sensors, we had some local sensors. So we were actually getting a lot of intelligent information. It could be a human intelligence. Then we used to get electronic warfare. That means emissions. That means an aircraft, a Pakistani aircraft takes off somewhere. Sorry. So there is an RF energy which comes, and that energy, if we is picked up by any of our border sensors, it comes to a platform. We have got sonar, which is basically your underwater domain awareness, and we have got radars, basically any ships, or any aircraft flying, or any emission coming from in the space. These are, and we have got a historical database. What is the historical database? In peacetime, we keep collecting information. When we go for exercises, we see some Chinese ships, we keep the signatures. Signatures can be in vibrational mode. That means how much of sound it is generating, how much of IR image, infrared image it is generating, and we keep correlating this information over a period of time and how it happens. So these are all the source of information on one side, and this source of information, this is where the AI plays the most important role. Though we are not very, there is a lot of opportunity. There's a lot of opportunity for AI to play a big role here. So we're talking about the data fusion domain. When we're talking about data fusion domain, this data is coming from different sensors, and they will be having different values. For example, some sensor will say +5 volt is a bit 1, and some sensor will say no, it is an analog sensor which will say 125 volt or 110 volt is a digital bit of 1. So how do we integrate them? So first thing is we do a pre-processing. And thereafter we do object in a refinement. That means we make it to a common grid. We make it to a common standard. The data is brought in, and with this data comes two important difficulties. One is the latency. Latency means the time the data actually takes to travel from a ship, or from a radar, or from a network to your ship where there is some action going to be taken. So we have to take care. Statistical models have to be built, algorithms have to be built, who basically take care into this. And thereafter, based upon the situation, what works out, considering the statistical errors, we come to know what are the threats. And we thereafter, say for example, when I say a threat, for example, there is an aircraft. Which is very close, or it's an enemy aircraft with an intention. It is coming towards, say, Jamnagar refinery. And there is possibly another aircraft which is going away from MUJ air base, which is actually an enemy aircraft going away. So when it is a aircraft which is moving away, he poses less threat to me. So there has to be a threat assessment, there has to be a threat refinement, and there has to be a threat ranking. Once I get the threat ranking, thereafter I activate my procedures. My procedures means whether I engage it with a missile, I engage it with the aircraft, which I engage it with a land battery or an army battery. So that is where it does. And all this thing is supported by a huge amount of data which is coming here. Now, where we are lacking today is this data is in different way. Data is lying in bundles and bundles of experience papers. It is lying in the mind of people like me who have got some experience, but it is not possibly coming into the system. And that is where we want to graduate from this to this. So this is the standard OODA loop. This is what the Forge works on, and it was discovered somewhere in the Second World War. Now what happens is, if you recollect, there is a demand. This demand is coming from the naval headquarters or the strategic headquarters, that there is, what is this demand? The demand is like this: there is possibly a buildup of troops here. do something about it, do something as per your SOPs. So this is the demand which has come to the fleet, which is their position in Vizag. So for example, so we observe the situation. But now you see what I want like to bring out to this audience, what was only pure electronic sensors giving us data, it has now got up more. Now we are looking into social media analytics. We are looking into, manual intelligence, human intelligence, and we are trying to say, can we connect up all together and make a comprehensive picture? Once we do this, then we start processing the data like what we did here. We start processing to make the situation, we orient ourselves. We are trying to say ye threat aa kahan se raha hai, whether it is coming from sea, coming from air, coming from space, or coming from where. So we are orienting our efforts there, and then we find all the alternative choices what we have. So here we are doing again, we are finding all a best course of action. It's like a allocation problem, like a transportation problem. So we are doing algorithms which are actually deciding which is the threat which has to be neutralized at the beginning, which is the one which is the most important, and finally we act on it. When I say act, means I have fired 2 missiles. I have fired 2 missiles from my fleet which is at sea, or I have fired 2 missiles from my army battery which is possibly in Mumbai, or maybe in Vizag. So that is what I act. When I act, obviously I'm expecting a repulse from my adversary. See, if you see what happened when we sent to Balakot airstrike, we were expecting, the moment we went and intruded into their airspace, we were sure that something will come back to us. And that is what we do, a continuous battle damage assessment. We report it, we deliver this all information to our strategic headquarters. That means the higher formations, maybe the political masters, and thereafter again the new set of demand comes. So this is the way a decision making goes. So what I want, this is a philosophical or a very top level view, but what I am trying to bring out the opportunities where I use AI, I use different type of techniques like computer vision, where I do data mining to see what happened in the past, where I build this database, and know what happens. Next comes how we have evolved. Please understand, sir and ladies, we started with a platform centric integration. When I say a platform centric integration, this was happening about in the early 80s when I had just joined fresh in the Navy. So what happened at that point of time? So we will find there will be a platform management system. So there will be all the data flowing, but it will be controlling only your pipes, your valves, your the oil flow, or maybe the power generation. Very important at the ship is the power generation. So these are called as I'm managing. So we work on 3 paradigms here. We want a ship, we say, to float. The ship's particular first role is to float, to sail, and to fight. So this set of information makes the ship float and sail. So how is the status of the stabilizers? How is the status of the propulsion system? How is the status of the power generation system? And once we are able to float, we are able to move. The next point is we would like to communicate with the world outside. We should know what is our position, what is our tasking, where we are in trouble or we are in a good shape. And to know this, to move this, we need a navigation system. So once we have got all these 3 functioning together, we are in a state in which we say that we are sailing and we are now capable. Now next comes the lower part. What you see is your war fighting capability of the ship. That means I have got a 3-dimensional radar which will be able to track any air targets. I have got now another network, like there are 3 networks. I have got another network which is a combat management system, and which is actually trying to correlate all the information and enhancing the combat efficiency of the ship. Now this is a probabilistic approach. That means given, please understand, it means given that the probability of this is 1, probability of this is 1, probability of this is 1, that means these 3 are met, then only the combat management system comes into play. And thereafter we have got plethora of electronic devices like a multifunction radar, we have a missile system, we have our guns, we have our sonars. These are called the weapons and sensors package, which actually helps us to meet our objective, do our vision, do our duty. So what has changed? Please understand, this is how when we are talking about platform centric engagement, so we had our sensor ranges, which are more, and then there are weapon ranges. So for example, radar may pick up something like 300 kilometers, but your missile system can only engage up to 100 kilometers. And this is my core, this is my defense. So these are my attack zones, and this E3 what you see is my defense zone. So what I'm trying to bring out, when I was doing a platform centric engagement, my first I used to ensure that I'm able to float. Next, I used to ensure I'm able to move. And lastly, I'll say now I am war worthy. Now I am war capability fighting. Now let me take up the war. And this is how the information grid flows. You see, there was so much of information. It was in my planning stage, so much of information. Then I filter out what is not important for me, and I come to my common tactical picture, what I say, which is my awareness grid. And lastly is my weapons grid. When I say the weapon grid means I am taking action or I am capable of taking an action. So please understand, ladies and gentlemen, I'm again trying to point out that from a situation which is a chaotic situation, I have filtered and made some actionable information, and from this actionable information, I am doing an act. This is nothing but a realization of the OODA cycle, which I just explained to you. And this is what is the phenomena or the philosophy of warfare. Now to add to this, I'm again trying to get the audience back to the context. मैं आपसे ये बात करने की कोशिश कर रहा हूँ कि नेवी के operations कैसे करके complicated हो रहे हैं. The next stage is, once we know about our air surveillance, now we are looking at underwater also, because underwater domain is very important. So who are the stakeholders? The stakeholders are the marine environment, pollution. So whether there is some ship which is coming and dumping some nuclear waste, or they are dumping some oil waste in our country or in our waters. There are corporates who are basically mining, and they are doing petroleum, so we have to give them coverage. Then obviously the national security, there should not be from any dimension any threat coming to us, and we continuously do science research and survey of our maritime domain. So this is how we normally do the sonars. This is a typical way the sonars work. They send some type of an radiations. The radiations come back to us, and we are also able to pick up from this type of sonar. We're also able to pick up the machinery noise of our submarines or adversarial submarines. That means this could be a Pakistani submarine. So these are our peacetime information. So when a ship is sailing, it has got sonars. It may pick up some, some noise, and this is what we do. We start fusing this information. We start fusing this information in different domains. When I say domain, that could be the speed, could be one. We could know what is the submarine's maneuverability. We have not seen the submarine. We can't come near to the submarine. We can see the noise signature. We can see the what type of frequency it is coming up. If it is a conventional submarine, in 24 hours, the submarine has to come up once to basically charge its batteries or start its diesel generator. So we should be able to find those things, correlate, and these are the database which we are building for our early recognition in case of war. So I hope with this, I would like to say, so what is the decision making step which we take when a platform centric? I'm again telling you again and again, because I want to show you how the warfare domain has gone up. So this is again a combat management system of a ship. So we have got all the set of sensors. We got all the set of sensors like an electronic support measure, which is actually just trying to analyze any frequency. So the moment someone communicates, a ship is communicating, an adversary ship. Adversary means the enemy ship is communicating with his pilot, which is in air. That will be caught up by us. Now, if someone wants to catch my information, my pilot is going, so obviously I have to decipher it. मेरे को उसको बेवकूफ बनाना है, and that is electronic countermeasures. Then is the communication intelligence, and there are different type of intelligence which are always work depending upon the situation. So very important part in our objective is the very good concrete situational awareness. Once we are aware what is the situation, then we have to filter out. We have to filter out people or the assets or the objects which is of no interest or no military interest to us, and that is called the recognition and identification. That means we recognize, no, this is a merchant ship, it is of no interest to us. No, this is a ship which looks like a merchant ship, but it has got an intention, it is coming towards some uncharted port. Maybe it is coming for some delivery of consignments, maybe it is arms for some terrorist. So that is what is we do our recognition, we do this threat modeling, we do identify. If we find that there's something to worry, we identify with the databases, and thereafter, based upon whatever number of balance in objects are there in our situation, we do a threat evaluation, and finally the weapon deployment. So this is the chain, or this is the kill chain what we maintain. So this is something how the ship is organized. So we have usually nowadays we have a common data backbone which we hear, which is called as we are talking of a service oriented architecture. So now if you see, gentlemen and ladies, I am moving on from a functional requirement to what an engineering guy should understand, that I have to design a ship, I have to design a warship, and where can I use the engineering principles. So this is where first I collect all the data into a common data framework. From there, and this data is coming in a two-way direction from the sensors and the actuators. Sensors are basically all type of electromagnetic, underwater, human end sensors. And then once I get this entire data, I process this data with my rule sets. What is the rule set? Simple सी बात है, I told you, if there is a receding aircraft कोई enemy का है लेकिन मेरी तरफ नहीं आ रहा है, बाहर की तरफ जा रहा है, he is no threat to me. So that is what I'm saying. It's sometimes, so we use a lot of mathematical tools like correlation, statistical correlation, fusion algorithms. Now this AI is actually an offshoot from this fusion algorithm. The first AI autonomous system or autonomous engagement of targets happened because of this fusion. We do a lot of hypothesis testing. So this is where your core algorithms come, and this is where the academia can really contribute in making our defense forces a very sharpened teeth. And finally, the user interface, what is visible to the user at his desktop. So now I would like to show you how we have evolved. So this was, gentlemen and ladies, what we spoke about, the platform centric shooter. There was a sensor, there was a set of sensors, but वो एक ही ship के ऊपर है, same ship. There is a war fighter, like a gunnery officer, like an air control officer, and then he shoots a weapon and the negates the object or negates the target. But today this is not sufficient because my reach is limited. Today we need something like platform to net centric, where this is cycles, such small cycles, such small assets are integrated through a network. So we have got data link, we got voice radio. See how we are getting more and more, our reach is increasing. Because if I have a very safe data link, please understand, data link means I'm passing data. That means I'm an aircraft carrier. मैंने यहाँ से 250 किलोमीटर आगे मेरा MiG-29 एयरक्राफ्ट या फिर मेरा सीकिंग एयरक्राफ्ट मैंने भेज दिया. I have sent it 250 kilometers ahead. That seeking aircraft or that MiG-29 aircraft has got an electronic suit which can see another 250 kilometer. So please understand, if he can send me the plot means the situation, what he sees 250 kilometers away. That means today I'm able to get, sitting on one platform, an information of 500 kilometers, which previously was possibly restricted to only 100 kilometers. That is the power of networking. But obviously, as I told you, 2-3 things happen very importantly, which we have to always keep in mind. First thing is the data latency. Because there is a physical time, there is a physical positional error of the aircraft from the ship, from the aircraft to the target, there is a positional error, there is a time. So those entire time has to be compensated. We have to have time-stamped data across the network, across the fleet. The second part is, if this data is inaccurate, I'm launching a missile. I'm launching a missile, and if the missile is fed with inaccurate data, our whole objective of survival is gone. And the third thing what is very important is, I have to control my ships. It can happen my aircraft is just somehow, killed, or my aircraft ditches, there is some accident. So I have to, now the moment, please understand, the moment I am talking to my aircraft, I have given some information to my enemy. Or whatever best I try to write all type of crypto algorithms, but I have given some information to my enemy. He knows there is an aircraft carrier somewhere nearby, and that is where that is the challenges which we have to meet in the platform centric operation. So where does AI play a role in this? So see, the Navy or in any armed forces, the way we report is very standardized. That means there will be a standard way in which the radar information will be coming to the ship. And if That is nothing but some bits and bytes today. If we can do some type of compression algorithms, if we can build some type of compression algorithms so that so that a small burst will carry all the information, that is the challenge we are working with. Please understand, if I have to say to identify a target, I have to give out say 5 GB of data. Can I not develop some algorithms based upon pure hypothesis, mathematics, pattern recognition to get that data from 5 terabyte to say possibly 1 terabyte? When I say 1 terabyte, iska matlab ye hota hai my RF energy which I am pumping out, the RF for the time I am pumping out, my radio set is pumping out in air is reduced. That means my probability of detection of my radiations by my enemy is reduced. And that is where AI can play a major role in this. So this is where I would like to show you exactly what happens when you have a fused information, correct information, and more sensors and sensor networked information. So if I have got just 3 sensors which are there on a ship, this is what I would look like a target. And if this information I give it to my missile system, the missile system will say, you please fire 3 missiles. Each missile is at least 2 crores. Whereas if I have got information coming from various sensors like the information grid, this is the standard error what I get of the target. My missile system will say, okay, you fire only 1 missile, there is a probability of hit about 80% chance that this target will be lost. And this is where, if you see over a period of time, from a platform centric warfare where the time of engagement and the number of targets destroyed is here, look here, I would like you to draw your attention. Say, for example, this can be 10, this can be 1, this can be 2. I'm just trying to give you some relative improvement. You see, it was taking so much. Oh, sorry. So it was taking so much time to engage one target, and now it is doing multiple targets in much lesser time. Now, this is called as a concept of cooperative engagement, which comes next. So look at this slide, sir. We are saying that today we have to be engaged in operations, and this is where our all efforts with the Ministry of External Affairs, our political will, our political alignments work. This is the NATO forces, they work like this. So you can have a US. So here you see there is an undersea fiber. So undersea fiber is giving the entire underwater domain information to the United States Navy, and it's sharing it with the Italian Navy. Some part comes from the United Kingdoms, and that is the satellite communication. So through satellites, the information is targeted. See, this is a remote pilot vehicle, RPA. This is a drone. This drone is giving information to the UK Central Command, and from there it is passed on to the entire spectrum of the Navy. I mean to say the NATO forces. And what all the other things? You can have a line of sight radio frequency communication where you are actually able to see an enemy target. So these are the ones who are seeing the enemy targets, and they are passing on the information to all over the chain, up the chain. So what do we gain with this type of a cooperative engagement, which is called as, we are looking at an interoperability and joint command and control. So if you see in the papers, you will find India is right now also India is having naval maritime exercises with US Navy, with Japanese Navy. And if you recollect about when Galwan happened, immediately after Galwan and Wuhan virus, there was China wanted to actually dominate Taiwan. Taiwan is a British colony as per their understanding. So they wanted to sort of control, blockade Taiwan. So what happened? US forces came, Indian forces came, and we all made joint operations. That is called as the presence, force protection, and force projection. We projected कि दादागिरी मत करो, हम भी हैं तुम्हारे साथ. So what happens actually? So this is where I was trying to bring down. See, when we are getting information from so many sources, there are so many latencies. One information coming from satellite, one information coming from an AVAC, early warning system. So they all come. Something can come from shore. When the information is coming from shore-based sensor, what are the challenges? There are some fade zones. There are some black zones where the RF energy will not travel. There can be rain, there can be clutter, which has got multipath effects. There can be some horizon limitation. हमारा horizon earth round हो गया, तो shore का कुछ limitations हैं. What happens when you are doing at the ship? At the ship again, there is a horizon. Normally from the ship, the earth bends from a ship. If you see and the height of an antenna, the earth bends to from 150 to 200 kilometers, and that is all the information a ship as such can get. And then there is multipath effects. These sometimes help us. Multipath effects sometimes help us. So we need noise cancelers for this. These are all adaptive signal processing. A huge amount of AI work is is available and possible here. And finally, jamming. Jamming is something like, if I'm transmitting into my aircraft, I'm transmitting to my aircraft from my ship. Someone understands the pattern and he transmits back the same information to me, and I at the ship think that it is coming from my pilot, and I give him some directives, whereas it is coming from the enemy jammer. So that is called as jamming. So we have got ship and we have got air. All these challenges have to be overcome. Why? Because we want to make a composite track, a composite picture, one particular target. With there may be few of these targets, and we have to say, okay, this target ship number 1 takes, this target ship number 2 takes, or maybe these 3 targets ship number 1 takes, which is called as cooperative engagement. So we are leveling up. We are leveling up, and our engagement strategies. So this is exactly what a kill chain of a ship looks like. This is a USS ships Arleigh Brook class, and you understand this ship. Please understand, ladies and gentlemen, I want to like you to just put your attention here. There is some sensor this is the kill chain. This is the timing of the ship, how it works. So there is a detection. There is a detection time. Once there is a detection, there is a classification. Yes, that there is a target. This is all happening inside this ship. So there is a naval combat management system inside. So there may be possibly a target, and this is a ship, aircraft, which is launching another missile towards the ship. Please understand, it is launching a missile. So there is a detection zone. There is a classification zone. It takes time. Then there is a launch. This possibly target has been launched. I mean to say, the missile has been launched towards the ship. This aircraft is of no fear to us. It's just a carrier. Aircraft is just a carrier, but this missile is a threat to us. The missile has launched. Now, when the missile is launched, it is again detected. You suddenly imagine the RCS, the radar cross section of this target, and the radar cross section of this target is quite different. So there is a likelihood of an operator error sitting on the ship. And believe my word, I'll give you a simple example, and it is from my own past experience. If a target is coming towards you at something like 250 meters per second, and it is a sea skimmer. When I say a sea skimmer, means a target or a missile coming towards, skimming the sea, 5 meters to 10 meters on an average, it will be traveling over sea. When it comes to me, my best of the detectors cannot detect before 18 to 20 to 25 kilometers. Please understand, this missile which is fired at me, if it is at moving at 250 meters per second, so it will come to me, and I have to, within this 18 kilometers or 20 kilometers time, I have to launch my missile and kill it. And the whole engagement cycle is just 16 to 20 seconds. An engagement cycle on a ship, the operator gets only 16 to 20 seconds, maximum 25 seconds, in which he has to take a decision, and the decision is not the operator's decision, because if by mistake he fires it at a fishing vessel or another merchant vessel or a neutral neutral ship, so we are gone. So that is what I'm saying. The decision making isn't just in seconds, and I have experienced it. That is why I can understand. So what happens? What we are looking for here? Can we somehow increase this detection and classification, increase this range from about 20 kilometers to maybe about 30 kilometers, so he gets 10 seconds more of reaction time. So please understand, sir, ladies and gentlemen. So we said we start from detection, then there is a launch of the missile, that is this missile, and once launch missile, then this ship has got some alternatives. He will try to engage it through a long range missile as far as possible away from its own ship. If that is failed, then it will come to a short range missile. And if that is failed, then it comes to a close range defense missile. And then finally, if it fails, then the ship is gone. And that is the impact. So what I'm trying to bring out, this entire chain today, this is called the kill chain. This kill chain is today within a minute. This kill chain is within a minute. So we want to increase this. We want to deploy our sensors and increase this. So this is exactly, if you see, it's like a game theory. It's like a game theory. So you have from the ship's perspective, and this is the anti-ship cruise missile, which is fired from the aircraft. So there is some type of a threat activity, and then there is a detection classification. Please understand, the ship has seen a threat. Possibly the ship has, what is this threat? The ship has seen an aircraft, or it has got an information there is an enemy aircraft in its domain. And then it is trying to detect, classify the target. Now the enemy ship will fire a missile. That missile has to be classified, because there are missiles which have got different ways of working, and we have to understand that. And thereafter, we have to, this is the launch and fly out of my missile or my weapon to engage the incoming missile. This is my launch time. And finally, what happens? There is a probability. The moment I open up my missile, that basically means I'm opening up my RF sensors in some way or the other, and there is a likelihood of me getting detected more, in a much better way by the enemy. So I'm opening up my defenses. So we normally go in enemy area. We normally go with total radio silence, and thereafter the ship is becoming vulnerable. Vulnerable means there is a likelihood of me getting killed, and there is the ship's killability. If killability means there's a probability, if this particular missile comes and hits the ship, will the ship totally go down, or it will be a gradual, loss of its operations. And finally, can the ship, even beyond all this, can the ship survive? So this is from the ship's perspective. These are all mathematical algorithms, and this is where AI can play a huge amount of role. And when I'm talking about your anti-ship cruise missiles, anti-ship cruise missiles have got something called as a homing head. They are the ones which are actually projecting information, or I mean to say projecting radiations. A missile, anti-ship missile, is actually a fire and forget missile. No one is expecting the missile to come back and reuse. The missile is gone. It is like a bullet. It has to hit its target. So it is like suicidal mission. So he has to also detect the enemy ship. This is from the perspective of the missile. He has to detect the enemy ship. He has to launch. He has to observe my missile hitting it, and thereafter the same. And there is a probability whether the missile will hit the ship or the ship will hit the missile. So these are basic mathematical probabilities. So now the next stage, I want to see how the warfare has gone up. Look at here, sir. We are talking about ICBMs today. We are talking about there's a launch pad, and this could be a Mumbai center, for example, Mumbai, and this is a Pakistani ship or a Chinese ship. It is firing, or it could be a submarine. It is firing towards our aircraft, towards the city, towards the city. So today we possibly can put always a ship at guard, and the ship can take care of firing a missile, the kill chain. But what can the ship do? Only this is what you see, this cylinder. This cylinder is actually the volume of space the ship is capable of handling, because of its sensor range, because of its weapon range. So this is what the ship can do. Now you see how the thing becomes more complex, and if possibly, if I, instead of one ship, now you will appreciate the network centric operation. This is a platform centric solution to an ICBM, intercontinental ballistic missile, coming and hitting a city like Mumbai. Now if I, instead of one ship, if I have a network of ships, so one ship, they immediately, when this takes off, this ICBM takes off, so if you please understand, this area of influence, or the area of information, area of action, has gone up phenomenally, because now I have got ships which have got at different positions, all of them capable of firing at a missile at not one point but at multiple points. And this is how the Patriot system, or the Iron Dome system of the Israelis work. Now let me just put one more aspect. And now see, from a platform centric to a centric in which we are looking at only ship centric, network centric. But now what happens when a space is coming? These all aircraft, this satellite is controlling this particular launch of the ICBM. This is a rogue country. This is Mumbai, and here my satellite is giving me information through the network. So this is how the spectrum of war has gone up. Please understand. You all will be very happy to note, or it will be it's a big learning. See, this is the 10th of September, 3 days from now. India is going to get into a very unique league. This is INS Dhruv, and this is the first nuclear missile tracking ship. So any ship, any nuclear missile. So this is all the satellite communications which we have. This ship is going to be commissioned in the next 3 days time, and on 10th of September. And any rogue missile or any rogue country trying to fire an ICBM, or maybe a high atmospheric re-entry type of an aircraft or a missile on us will be detected by this. And this is totally network centric. So we have made huge progress, and we are possibly the fourth ship. We are fourth country to do it. So what is the value chain of the naval warfare? This is what I would like to tell you, sir. We started, as I told you, this is the value chain. Up the value chain we have moved. We started from basic RF sensors and systems, which was platform centric. Then we moved to air. We got aircrafts. We got early warning aircrafts. So what we got is command, control, communication, computer, intelligence, surveillance, and reconnaissance. So we have come to a domain of C4 ISR systems, which are feeding these are all remote piloted vehicles, anything you can see, drones. And that information is getting integrated to our common operational picture. From there, now we are saying, so this is our sensor grid has gone up. And now our sensor grid has gone up. Now our engagement grid has gone up. Why are we trying? So why can't we? So we have bought the S-400 missiles from Russia. So what can it do? It can basically increase the range of its engagement all across the Indian coastal borders. And finally, with the integration of the space, so this is where the technology is moving up. Or ho kya raha hai? We are getting the information, we are getting multiple information. Our bottom grid, please understand what is happening with all this. Our bottom grid is getting chaotic. बहुत ज्यादा पढ़ रहे हमको information मिल रहा है, data मिल रहा है, at the fly मिल रहा है. इस डेटा को कंप्रेस कर रहा है ताकि हम इस पे एक्शनेबल इंफॉर्मेशन ले सकें, and we can engage a target. This calls for huge opportunities for AI algorithms and big data analytics. What we are looking for. So some of the existing concepts which are there. This is the Tomahawk anti-ship missile, which was used extensively in Iraq and in Afghanistan. And then these are some of the submarines. You see, you have got a captor system here. You are just embedding the system. Please understand, you are embedding the system in your seabed. It is like a mine. The moment there is a submarine, because any submarine in your waters, in our waters, 200 kilometers from our coastline is our exclusive zone. And no submarine is supposed to be dived. Though we go for war patrol, we also go into their domain. They also come into our domain. We are aware of it. But here, like a capture system, the moment it finds a submarine, it has been tuned, fine-tuned. It has used all the adaptive signal processing to ensure that the moment a submarine is there, it will be able to fire a torpedo. It will not fire a torpedo on a ship, because there will be thousands of merchant ships floating around. So this captor, so this type of decision making within this small embedded software, which tells you that no, this is a threshold, this is a submarine, I have got enough information of fusion information to say this is a submarine, and then only you fire a torpedo, makes a difference in our warfare capability. And this is what the Aegis system does for the US. So here I would like to bring about, now I'm moving on to the architecture. So now I have given you a broad thing. Now I am trying to say what happens with so much of data, how are we handling so much of data. The Navy is also going through a digital transformation, and how it is happening I would like to bring about on this. So these are some of the recent trends, in recent information which all of you must have noticed. So we are seeing this. This happened in Jammu and Kashmir about a month back. There was a remote piloted vehicle. That means a drone which came, and the first ever drone attack on the Indian military base. If you see here, you saw the movie Uri. In this movie, basically, this is like a Garood, and it is like giving us the target information at a low level conflict. We are getting into a low level conflict. Like if, for example, there are some terrorists hidden in some place. So this is the one which is giving information. All this processing needs a lot of mathematical capability. So what I'm trying to show you here today, there are 6 of these aircrafts which are stranded at Kabul airport. These are all civilian aircraft stranded, and Kabul says, no, we don't have any aircraft. We will not permit any military aircraft to come, but there's no civil aircraft. This is how the world is getting a situational awareness. I would like to narrate you a very small incident, how the AI technology, the first war, or using modern AI-based weapons is here, and that was nothing. On 27th of September, the war was fought during the COVID times, from 27th of September to the 10th of November. So this is the area. It is like 2 countries which have come out of Russia, independent, Azerbaijan and Armenia. And this is Nagorno-Karabakh. This is the area of conflict. It is like, you can say it is like the Jammu and Kashmir of between these two countries. Now, what is happening? Ethnically, this place belongs to Azerbaijan, but Armenia in 1994 in the last conflict was able to take over this particular area. And now what has happened in this latest conflict? This is a boiling hot pot there. There was a big war. Armenia is a small country. Azerbaijan is a big country. In 1994, Armenia was able to defeat Azerbaijan using conventional warfare. But today, what Azerbaijan did, it prepared itself for the war. It got drones. It got drones from Turkey and Israel. And they are so precise, ammunition drone. I just want to show you a quick video. If if this class can, if my audience can understand. See, this is how these drones have played havoc in the world.
Azerbaijan's forces. They're known as kamikaze drones, and they've given the Azerbaijan military an edge over its enemy. Azerbaijan's president Ilham Aliyev has bragged openly about procuring drones from Turkey. Experts say that Azerbaijan has amassed a sizable and diverse fleet of unmanned aerial vehicles. The word kamikaze refers to fighter aircraft used by Japanese pilots in World War II, when deliberate suicidal crashes into enemy targets wreaked havoc. It is now evident that kamikaze and other similar drones are littering the landscape of the disputed region of Nagorno-Karabakh. These drones can take out tanks and artillery, which hold strategic high ground which was previously impossible for Azerbaijani forces to recapture. They can circle a target for hours and then dive down to self-destruct with a payload of explosives.
We noticed a UAV in the sky. It is called kamikaze. It finds moving objects, gets closer, and then blows them up. It explodes and spreads shrapnel. The majority of victims are a result of these.
So just I wanted to bring out how AI has actually changed. So today we are not looking at, first thing, how the warfare has changed. We are not looking at a full-scale war. We are looking at local wars. We are looking at low intensity conflict. Area is well defined, but the aggression changes. The level of aggression changes. Technology has taken a new level. So I would like to just read out two particular things. This is from the Pakistanis, how they have started fearing it. So this is from one of the Pakistani sites. The region of Jammu and Kashmir, like Nagorno-Karabakh, is geopolitically a flashpoint in South Asia. Given the obvious disinterest in the international community in resolving the protracted conflict, India, Pakistan too repeatedly finds itself at the brink of a military conflict. Hence, while drawing lessons from the encounter in Nagorno-Karabakh, Pakistan must also carry out a renewed security threat assessment and review its military capabilities. It especially needs to take into account the new vulnerabilities that might arise in wake of emerging technologies as the new entrants of the future battlefield of South Asia. So you see, there is already a realization in those, and this is from an Indian side, how Azerbaijan's drone power brought Armenia to its knees. Is India ready for a modern warfare? So the concept, the conflict today, we are not looking at very huge fleets, very huge carriers, very huge fighters. We are looking at small, and that is where our Indian industry can help us. That is where our ecosystem can help us. So now the next point is, how is the AI ecosystem going to change the battlefield space? Now, this is where we are looking at. So these are all the points where we are trying to ensure that there is, crypto and cyber security is there. That means we are hardening our systems. We are hardening our military hardware, firmware, and software so that there are no holes. Whatever we try, but there will always be some holes. So the hardware infrastructure, that means the storehouses, we are looking at a cloud. We are looking at a cloud within our premises, on-prem. And once it gives us, so we are getting a lot of data repositories. When I say the data repository, it could be how the way and time of the day the ocean is working. So what are the ranges? What are the ranges which a typical class of ship will get? Ranges means at what range it will be able to detect its threat. Our satellites, how much time it will take to detect a threat, with how much of errors the threat will be detected by a particular satellite. So all these data sets, a huge amount of data sets are being captured, and we are training our AI model. So this is where a lot of algorithm work which the industry and academia can participate in. Again, from here comes the logic. This logic is obviously there is some out of box thinking has to be done, because the military commanders will most likely be looking into the conventional warfare. So today we need young minds who play dynamic games, to think. So there is an art of war. This art of war has changed. So we are looking at some type of software repositories. We are looking at integrating these software repositories with the data. We are looking at open source databases. We are looking at open source information, open source software, which can be customized for military needs. And obviously we have to change the way we develop our systems, we operate our systems, with always the security embedded in it. And finally, when the applications are made, they are deployed, they are delivery digital services which are being deployed, we have to authenticate that who is the one who's accessing that information. So entire information is coming here now. So we can't have any type of pores in this information for any adversary to get into hand. So how the battlefield has changed, sir? Please understand, here we are looking at an operator who is a man in uniform, who is into a platform, but he is helped online, real time, by developers who are continuously monitoring, writing new algorithms, and supporting the man in field. We are looking at a developer who's possibly he's the delivery of the developing team, and possibly there is a huge R&D development system behind, and there are some hardcore academia, hardcore researchers who are contributing to generating new models. And this is where India has to fight its new war. So this is the sort of a road travel we have to. So we have to have data, we have to have a business intelligence, we have to now get into very smart networks, trading this data, training our engines. And obviously we are soon going to be into the era of quantum computing. So I would like to see where today we stand. This is just a indicative slide. So here we have a platforms, we have an operating system, what we call it, the enablement of the digital world. Then we're talking about a middleware. We're talking about a middleware which is a service oriented architecture, and this is how things are working. So we have a pocket, or a silo of algorithms. These algorithms get embedded because some type of a situational awareness need these algorithms to paint a picture in front of us. So this is the architecture what we're having today. So we'll have a training and simulation, we'll have our video processing, we'll have the GIS maps, we will have a system management. Should there be a failure of this, there should be an alert, and there should be a external system interface. When I say external system, means a radar, a network system, maybe some a satellite information, maybe a meteorological information. So all external systems, we are having a record and replay. The entire battle has to be recorded, replayed, to know or learn what has gone wrong. We have got sensor modeling and management systems. Then we have got track management and data fusion, very important part where AI is playing a huge amount of role here. These two blocks, AI is rich in this. We have got intelligence analysis, another place where AI can play a major role, and obviously data crunching, maintaining the data, finding insights, finding patterns, and that is where we are looking at. So finally, what comes at the topmost layer is the operator who is controlling and looking at some picture and working. There's a weapon management or a weapon engagement, possibility. There's a tactical planning, abstraction, and constraint mapping. So this is where we stand now, but definitely we have reached. So what we are looking at is a digital transformation. What the Indian Navy, what the government is looking after is in digital transformation. So we are saying there is a backbone, sensors, there are decision makers, they are effectors, they are the missile systems. So this is where we are looking at. We are looking at from the ship, from the tank, the battle space, the satellites. This is the social media, analytics, videos. We find as simple as that, from some police organizations, and also the industry and academia. So, and this is the global partners in peacetime when we are exercising. So they feed us a lot of information. This is the value chain up what we are looking for. So what it will give. So we have started work on this digital backbone. What are the impediments? Kya problem hai? The first thing is the technology core is too fragmented, fragile, insecure, and obsolescent. We are running ships which are 40 years old. So how can we have a new set of data, a new set of sensors being put there. We have got data which are always in in internal silos, because we always had this mind, security, safety, ye data isko nahi batana, ye data usko nahi batana. So obviously we worked in silos. We had critical digital and data skill gaps. We are men in uniform, and most of them are men in uniform. They are not digital programmers. They have a different mindset. So our selection itself is from the Second World War, what the Nazis did, the service selection board, and that is where. So do we need? So it's a question mark on us. Do we need? How do we? What should be a digital trade? And we have to remain mired with the industrial age process and culture. We have to change our mindset. We have to change our minds. No, we can't do. Our senior officers or the government machinery people can't say, "यार मुझे तो समझ नहीं आता ये computer कैसे चलता है. I have an assistant to work for me." No, you have to be digitally ready, and that is the challenge what the Navy and the government is facing. So what we are looking at the information in the full spectrum, fixed assets, and our mobile and deployed assets. So this some part, as I told you, has already happened, and this is what we are calling at a service-oriented architecture. So previously, what was happening? Please understand, previous models were something like a client and a server. That means there is a client who is requesting an information from a server, और वहां से उसको reply आता था. So this anyone in a computer science would understand there are 4 Ws which this client server model wants. And what are the 4 Ws? Who is asking the information? Where is he going to seek the information from? What is the structure of the information from? And when is the information required by him? So today we are talking of an enterprise data lake. We are talking of a global data system. We are talking of an information model where we are saying there are publishers. These are the sensors. Could be a radar, could be a sonar, could be a satellite. It is just publishing a data, and it tells you right in the beginning, it tells you what is the quality of my data. I'm going to give you an update for every 5 milliseconds. My data will have so much of standard error. So that data is coming, and this subscriber is your effectors today. A missile system will say, no, 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 I'm not happy with this data. I'm possibly more happy with this data. So he picks up, it's like a well, like a data enterprise lake. So this is where the warfare, this is where the system design is moving on. So this is called the service-oriented architecture. This is how it has been implemented. And what it happens like a smart city project goes like this. So if you see, like you have got some data coming from computer visions, you are coming some data from RFs, you are coming some data. Now these are, when I say a primary radar is normally like a track while scan radar. Whereas a secondary radar is like a gunnery radar, which is a focus, it has got a pencil beam. And from this, the same target information coming from multiple sources, and thereafter we are looking at our database like a data processor, what possibly the flight could be, and this all information is pumped up in this global data space. And anyone who wants this data, anyone who a security, a safety guy wants this data, a traffic controller wants this data, he pulls out what he wants from here. So this is the type of autonomous data management systems we are looking at. So this I would just like to tell you like how we are looking at the Navy as such is transforming. So we are looking at the data at the center. Here we are looking at some of the hardware which are hardened hardware for our services. Then we are giving it the basic services like the processors, the technology we are trying to adapt. Then we are looking at the standards, the best practices and standards. We are looking to mine the data and get knowledge management, and thereafter we are looking at the intelligence. So we are building intelligence. These digital services are then handed over, if you see, to our people, to our different pillars, what we call of the Navy. So what are the different pillars? One is the operations we just saw. Then again the ships, the submarines, the aircrafts, independent platforms. Thereafter we are also giving it to our yards and material services. We are like a supply chain management. We are looking at our assets, which are the repair assets, which are our dockyards. We are looking at giving all this information, training our new soldiers and making them data enabled. We are looking at a human resource management like healthcare. So we are trying to embed all these features within the data management system. And this is the healthcare. And then we are looking at a knowledge management, and finally the journal administration of the Navy. So we are getting digitally enabled to help whom? To help our stakeholders. Who are the stakeholders? Firstly, all the Navy, the serving officers and men who are there on the ships. All our civilian and the support workforce. Navy has got huge amount of civilians who are working, the research organizations, the repair organizations. Then we are looking at the veterans like me. who are also dependent on the Navy because of so much of graying we have done. We can also contribute to the concept of operations. We are looking at the families. The Navy is a way of life, so it looks after its families. And finally, we are looking at collaboration across cities, across organizations, across countries. So how do we handle so much? We handle by this. This is one of the representative way, as I'm talking of a systems engineering, or you can say a system of systems engineering. So here, what we are, this is the IBM model of harmony, which we practice, which we have experienced on. So here, what we are looking at first is we make our, our requirements, our data as a repository. We model the data the way we want it. Thereafter, we design what type of functionality we want from the data, and then we start building across the data and the functionality our small systems, but they are no more in silo. Now they are all network connected. They all are a continuous it is a continuous development, a continuous dev, sec, and ops. So what are the emerging technologies which we know? This slide is very common. So you have the data here. We are security driven, security conscious. We have set up a data governance and integration management system. And now we are trying to build intelligence in our system. How? Through autonomous things like autonomous weapons. I'll show you a couple of few of these examples. We are talking about analytics, augmented analytics and artificial intelligence. We are talking about digital tools like digital twin, 3D prints, immersive experience like AR, VR. These are the ones which we are already into it, and we are looking at things like distributed ledger, blockchain technologies. We are looking at cloud computing. We are looking AI at the edge. We want today. We don't have mobile phones, which we don't have mobile phones which are secured, but we are trying to build our own mobile phones with our own operating systems. So these are the defining technology of 2020s, and how we are trying to merge this into a culture, an organizational culture. So we are looking at collaboration, we are looking at process enhancement, we are looking at small programs aligned to the digital transformation. We are doing a lot of research and training, and these are the places where there's a lot of ecosystem availability for young brains. So this is a digital maturity curve, so I'll not go much. I will show you some of a few slides. I will show you what are the different types of emerging technologies we are looking at. You saw how havoc the UAVs and the drones can play, so we are working heavily into this. These are from the Boston Dynamics. They show how today when there is a mine infected area, so there are so many people. So if you recollect, if you see of late, the para Olympics are going on, Paralympics are just concluded. Most of them are ex-army men who have lost their hands or feet or some part of the body because of mines. And this is a statistical study. Can we not save them? We are having youngsters who are dying at the age of 21. Man gets commissioned, he goes to Siachen, and by 22 he's dead. Noida, where actually I stay, it is full of those roads which are named after these people who died in Kargil war. Can we not start thinking about such type of robots? Now we are looking at when the Siachen, our troops are there. So there is something called as a khachar. Khachar is like a cross between a donkey and a horse, but they are prone to they can die. Can we not have the same thing done by such type of robots who can climb a terrain and carry the package? We are looking at automatic tanks. We are looking at soldiers today. Even China and US have got platoons. They have got platoons who are actually soldiers who can work like soldiers. So we are looking at co-workers who are machines. We are looking at co-workers who are machines. So we are looking at snipers, perfect snipers. So what all was there in the movies, the generation ahead is actually being there. So this is what I was just trying to tell you. There is this possibly maybe a conceptual drawing, but today we are talking about soldiers. We are talking about soldiers who are autonomous, who can take some decision, though there are legal aspects on this. Today, space is weaponized, space is militarized. I just showed you how can ICBM be controlled at space. It can be given a mid-course correction. For example, a rogue state fired an ICBM at Mumbai, but it gave a mid-course correction to drop the nuclear head from Mumbai to Delhi. That can be done by space. So we have already reached a stage of weaponizing the space and controlling the entire situational awareness using different type of computer vision or satellite vision to know our territories, to know our adversaries. Today we are talking about bombs. We are talking about bombs where we are using principles of game theory. Today we are saying, what will Taliban do next? So I don't think the Indian security establishment is sitting tight on it with whatever has happening. We are looking at co-partners and co-workers in logistics, procurement, military farms, the audit of the military farms, optimization of logistics, deck operations. With deck operations are very repetitive operation. A ship is, even today, a ship is tied to the jetty. So can this thing of throwing a tying line by a man, instead of that, can it not be done by some equipment? So we are looking at deck operations being automated. But as I speak to you, our spectrum of conflict, which we started before, a platform centric to net centric to different electronic sensors, has now gone up again. And this is where we have to be prepared. What are the new models of our warfare? You see, cyber warfare, it is completely can be only challenged or can only be neutralized with the use of AI. Economic warfare today, our economy is down because of this pandemic. We had an effect on this. Food security warfare, what happens if our adversary is able to inject some type of small bots which actually kills food? And what happens? We are water warfare. Water warfare basically means blocking and releasing. Brahmaputra major part is in China, it can open up anytime he wants, and we are flooded. And what happens? Our information and social media warfare, this we all are aware. Today India already is perceptionized as a as a Hindu national state. There is a perception. I'm not saying whether it is there or not. As a constitution, we are supposed to be secular, but we are being perceptionized. Taliban says today, I have got interest in Jammu and Kashmir because of there are Muslims there who are being prosecuted. So that is where the warfare dimensions have changed. We are talking of germ warfare. We have all witnessed it. These were all theories some year back, but today we know with the pandemic what is the germ warfare. So what does this, AI vision gives us for a military requirement? This is what was a conventional response. What happens? The fighter aircraft drops a bomb, huge collateral damages, huge collateral damages. The whole city is ruined. Iraq was ruined like this. Afghanistan was ruined like this. But today, if I work with my AI systems, no uniformed man would ever to kill an unarmed civilian. So we would like to break the strategic backbone, and that is what you break the you have precise ammunition, you have precise information, and you target only the critical resources. You don't target civilians and say, why should you kill people? You should kill assets so that he can. And that is exactly what Azerbaijan did during this conflict. We are looking at AI assisted machinery space. This is a typical naval warship, and this is a typical type of the chain, the pipelines which will go. Yeah, and this is where a man will always be there. He's got so much of vibration, noise, machinery is running, auxiliaries are running, so much of heat. This temperature would somewhere be about 40 to 50 degrees centigrade. There's a human fatigue. Can we not reduce this to make something like this a machinery space? There is a Google Assistant or something like a Google Assistant, and it tells us the temperatures are going on. There are enough sensors. We are looking at AI at the edge, though it is not very much, it is still a practice, a phobia amongst the services to use, mobiles, but there is no way we can stop it. So rather we would like to hardcore, embed some software. We would like to make our own operating systems, and work is going on in that. We are talking about digital twins. Today, when I am doing a shipbuilding, aircraft modeling, I don't have to build the entire infrastructure. Today, I was told about 1 month back, if you remember INS Vikrant, which is supposed to be our first indigenized naval aircraft carrier. It was supposed to sail, and the machinery system developed a problem which was actually handled only by the Italian OEM. OEM is the original equipment manufacturer, and he refused to come to India because India is somehow, he had a Delta variant fear. So what did he do? So he shipped some type of a virtual glasses where our people went wearing those glasses, gave the information. It was not even given. He just had to wear that, and it was automatically extracted and sent to Italy. He was given, got the parameters and told what to do, and the ship could sail, an aircraft carrier. Unfortunately, please understand how much we are tied down because our industrial, it is not supported by our industry as of now. So we are talking about a virtual product, and we are talking about a virtual product. We are getting into the AI domain to design a product what you want. So I would like to show you a quick small video on this. This is from Siemens, who has given us a product on ship design. A quick video, if I can just, yeah, see how a ship design is held now. So there may not be any sound in this. So here the piping system, I can walk through a ship compartment. I don't have to go and look at for designs now. I can see this is a seawater line. This could be a freshwater line. This could be some other pipeline, and there could be an interface. There could be a problem. The compartment, how it looks like when it is complete. Everything can be done in a digital twin. So we are talking about. So this is installed in one of this laboratory has been installed by the Indian Navy in one of our establishments in Delhi, where we can actually do a design. We can see the design, how the design works, and make corrective maintenance, or rather, I was correct the design. And once the design is made, production becomes easy. So this is what is a concept of a digital twin, which I thought I must share with my audience today. So things like, we can make a ship virtually, see what type of propulsion systems it needs, what type of engine power it needs, what type of wake it can able to sustain. We can do it for aerodynamic performance for the ship as well as for the aircraft. So these are all a part of the digital twin, where I don't have to invest very heavily. Next point, what we see here for the Navy is a huge amount of predictive analytics. Today we are working towards it. We are having the backbone where the failures and the defects are being brought in. But can we do from predictive to prescriptive to cognitive maintenance? When I say this, it means पहले मेंटेनेंस क्या होता था, चल रहा था मशीन, जो मैन्युफैक्चरर ने लिख दिया कि 3 घंटे बाद या 3 महीने बाद उसका ऑयल चेंज करो. So we used to do it. Today we are saying why. We are asking the question why. And today the world is asking the question why. And that is why we are saying we are capturing the data. We are trying to predict. Can we do a text mining, data mining, statistical analysis? Can we delay? Can we reduce our cost? Can we extend the life of a machinery, extend the life of a missile system? And then we act depending upon what the insights of the data is. So we are also working on organizational knowledge, because the knowledge is there. Like people like me who have possibly retired from the Navy, there are people who have just written documents. There are a huge number of documents. The first step is digitization, do a keyword analysis, do something like what Google does, and make an organization which is knowledge imperative. Peripheral security, every naval base, army base, you see there are so many soldiers moving around. Today we are not getting into that. We want to reduce our soldiers who are on such type of work. Can the technology help us? Yes, it can. So if can be an intrusion service, it can be, the entire CCTV, the entire spectrum of security of a base can be handled. Terrain mapping, very important, is if I have to fight a war, I should know the terrain. So do we have the technology? Do we have the intelligence to build layers of this and get the accurate information? Because today we have got missiles which are terrain mapping missiles, like Tomahawk missile. It is a terrain mapping missile. Same way we are also developing. So we definitely need this terrain. So we are doing a lot of work on this terrain. And this is where I told you about the network-centric operation, how the architecture has changed from a standalone system when we come to a network system. So we are talking about network and communication infrastructure. We are talking of end-to-end cyber security, and then the systems engineering process. The systems engineering process, which tells us, how we can do. So we are working towards the military part. The offshoot is there are a lot of critical infrastructure like our oil rigs. So we are working on the similar way for our oil rigs, making them safe. So we are making them cyber physically safe, critical infrastructure and physical security. We are working hugely in this. And we are also talking about ensuring that our standards, the security standards, are always improved so that we are always ahead of the adversary. So again, last use case which I can say is a cooperative engagement, which you saw. There are independent ships giving all the information. They are together tracking, or they are having information from ships or satellites, and their reach is increasing. And we are talking about today, we are no more talking about a single aircraft. So we saw, if we recollect, this ship is seeing something. This is the situational awareness. This ship is seeing something. This ship is seeing something. All of them together is basically building a cooperative picture which is capable of being engaged by any of the ships. So what are the challenges? Some of the challenges where AI can help us is, a ship from a radio source will be just a blip on the PPI, we call it. Where a PPI is a planned position indicator. How can we distinguish between a cruise ship and a warship? I don't want to hit a cruise ship. I don't want to train my missile. I want to ensure that I give that much of information to my smart missiles today that it never kills a cruise ship. So this type of where AI can really work in. How do I know between two people? These are some youngsters who are possibly throwing some stones, or some youngsters who are dissatisfied with something, but it is their emotional outburst, but you are being sent to hold them, to control them. And how do I know it is just a guys who are just in some madness, who are from good houses, they don't have any criminal background, but here there's a guy who has a criminal background, who is like a Taliban fighter, very clear of his objectives. How do I distinguish? Can AI help me? Yes, it can. Here again, when we don't want to have any collateral damages. When we go into war, we are going with again a perception that we don't want to have a collateral. So Israel in a very recent war with Gaza, it actually displayed a lot of, it told, if you recollect, there were some videos. It told one of the news channels, that Al Jazeera, that you have done wrong reporting. I'm going to, bring the building down at so and so time. And there was a request, there was a video request which went viral, that Al Jazeera, his CEO, talking to the young lieutenant and saying, "Sir, give me 10 minutes time. Something very important is there." And that man says, "I told you in the morning, I'm going to get this thing down at 3 p.m. I will not wait for 3 p.m. and 1 second." That much of precision ammunitioning, that much of precision weapon delivery is available today, and Israel has shown us the way. And I'm sure our Indian ecosystem can also work. We are talking about unmanned vehicles today, unmanned maritime vehicles. We are talking about surface vehicles. We are talking about underwater vehicles. We are talking about torpedo systems. There is no human requirement here. And I would like to show you a quick. So these are a swarm. This is a swarm of sensors. A submarine is launching all these sensors. Please understand what is happening. A submarine is launching some capsules. These capsules are coming to the surface, and each of these capsules is carrying a drone. Imagine the submarine which is submerged in water, through its RF and RF and what you call sound sensors. It is able to get a clear picture. It is also getting what type of ships are there in its vicinity. This is what the UK Navy has done. So it has made ships which can detect, and it has reduced its own detection, its own radar cross section by stealth. We also have the technology in India. You see how the world is moving. Rolls-Royce is teaming up with Google AI on an AI-driven ship, totally AI-driven. We will not have any man on the ship. Can this be possible? Yes, it is possible. And I would like to show you a quick example of this. The US Navy today is exploring. Now, why I'm talking a lot of the US and all, because open literature is available. Indian Navy, such things are existing. I must assure this audience, but I can't speak because of those things are not there in the open. So we are talking about networks. We're talking about warfare networks. We're talking of the carrier, the submarine, the destroyers, all coming and collectively adding on to the information. So one video which I would like to show you here, a big thing. I would like to first narrate you a small anecdote. In 1971 war, this also happens to be the 50 years of 1971 war. INS Vikrant was our carrier, and it was off Bangladesh. It created havoc in Chittagong, and it fired naval aviation. They took a lot of lead in that. But PNS Ghazi, it was a Pakistan naval ship Ghazi, which was a submarine. It was sent all the way to the Vizag port to kill Vizag, to get down Vikrant. So what Indian Navy did, will you believe? Indian Navy, it was their leadership. What they did, they created so much of signal traffic, showing as if as if INS Vikrant is not of Vizag but of Bombay. And when PNS Ghazi concluded that yes, it is of Bombay, it was coming, it was killed by INS Rajput, Indian naval ship. And in return, INS Khukri also went down. We also lost one ship, but we killed PNS Ghazi. So what I'm trying to tell you, such type of deception is available, and submarine, finding a submarine in sea is just like finding a needle in a haystack. So today we are having autonomous, DARPA, which is the American, defense research organization. Look at this; it has got an autonomous sea hunter for submarines. Please have a look at this.
We've been at this for several years. What we're building is a large unmanned surface vehicle that's designed to basically stay out to sea for weeks to months at a time. It's got a lot of endurance, can carry a lot of payload, and it's highly autonomous. The DARPA program has really been focused on developing the autonomy to allow it to operate safely at sea and obey the rules of the road at sea, not collide with other vessels, and actually then hopefully do useful missions for the Navy.
So as the name suggests, it is Sea Hunter, and it has been a DARPA project, not a single man, and they can stay for weeks, autonomous piloting, autonomous safety, and they can hunt for submarines. So now last point is where I would like to just bring to the focus here, though I had a couple of slides more, but I think I have spoken enough on this. What are the research opportunities? Where do you find such research opportunities? So there are two platforms. One is IDEX. IDEX, if you can do some research, is the Indian Defense Exposition, and the other one is the DRDO funded. It's a technology development fund, TDF. So these are two primary keys where, whenever there's a requirement from the navies or from the armed forces, they encourage an ecosystem of startups, and huge number of startups have actually invested, huge number of academia is interested, and I have, being a domain expert, has been able to help couple of them to actually make up good proposals, because we understand, and we are a network of people who understand what is technology, what is the military technology. For example, we are looking for development of drones for carriage of stores in high altitude areas. Today drones are used. Today it's a soldier, it's a khacher which is going. Why can't we do it with the drones? We are looking for wireless aircraft data record, flight data recorder. That means today the flight data recorder is the last epitome, if the last thing, if there's an accident which gives you all the history. We are looking at what is called as a HUMS. HUMS is the health and usage monitoring system. That means if the fighter aircraft is in air, if there is an issue, or we can do some predictive maintenance, we can do some remote maintenance. The pilot is totally focused on firing a missile, but if there is some problem, it can be predicted, it can be told, his contour can be changed. So this is the technology development fund of the DRDO, and you can see here only nascent startups within 3 years they can apply for it should have not received any grant. There are some of the conditions which are there in the open domain. I'm sharing my presentation so you can have a look. So what is the purpose? The purpose is basically to encourage an ecosystem in India, particularly AI enabled, digital enabled, to get some use cases, to implement some concepts which we have learned over the period of years as the warfare has evolved. There can be what are the conditions have been given, the requirements, the submission of proposal, and how do you get the grant. Up to 10 crores grant is available, and even institutes, I know, like Vellore Institute of Technology, I know, there are a lot of people who have taken this. I'm sure it must be there in Manipur also. So with this, I think I have concluded my my lecture, and I'm sorry I may have taken I may have rushed through it fast, and I may have taken some more time, but I'm open for any questions if there is any. It will be my proud privilege, sir. Thank you, sir. Thank you very much. Great opportunity to be with you, sir.
Thank you, Abhijeet sir. So, dear participants, if you have any question, you please ask the question, or you can write in the chat window. Sambhu sir or Princy sir, Princy ma'am, can you please release the mic control to the student, to the participants?
Yeah, I'll do that.
Participants, you may write in the chat window also if not able to talk. Yeah, now you have control, participants. Please, you can unmute and ask the question, query, or anything you have in your mind which is related to this talk, or maybe which will, let's say, enhance your skill or help something somewhere.
So
No question?
was it very high
Okay,
edge?
so I think the talk is understood by all, or maybe everything is going above the head, right?
I think the only two ways. Yeah,
Okay,
yeah,
but
yeah.
talk was really, it is very nice, and I saw some of the topics really very interesting. Even it is, or it is required for today's development, right?
Sir.
It is required for today's development.
Yes, sir, yes, sir, it is required. So very much required, and we are, the Navy as such or the government as such is promoting the industry as well as the academia to partner with
Yes,
us. So
yes,
there are many. So we would like that culture. We would love
yes,
to see these youngsters, many of them and the academia participate in such a challenging projects, and then only we can, as a country, grow, sir.
yes. So I'll contact you, sir.
Sir,
So
please, sir,
maybe
please,
we can wait for 2-3 minutes.
sir,
Maybe
sir.
any participant can reframe the question or query and ask.
Yeah, you can ask a very simple question. आप मेरे को simply बताइए. If you're not able to frame it, आप कुछ भी पूछ लीजिए. I can handle it.
So, sir, talk about Industry 4.0, right?
Yes.
Train for product development, manufacturing, performance, right? So many aspects you see that maybe you are using in some courses what you are teaching at the fundamental level, and these may also use somewhere in your research work and even for developing projects, right? So I have one question. So, sir,
Sir, please.
do you have your how you work now? You have your institute or maybe some company?
Sir, this is actually Unlock Minds is my consulting. Unlock Mind Consulting is my own company, sir. And
Mhm.
I also work, as I said, sir. I work very closely with IIT Delhi. I do a lot of work with them through this Center for Digital Economy and Policy Research, sir. So I
Mhm.
am a founder of this institute. With this particular institute is training a lot of students for education in the education field, as well as we are doing some technology adaptation for them, sir. So
Right.
two of them, sir, and I'll share my details, sir. It's there in the presentation. I'll share the presentation. My last slide has got my email and my mobile number. If there's anyone who would like to have something more than this, would like to look at it for some opportunities for collaboration, would like to understand something, or would like to just join the armed forces and know something about the armed forces, I'm always there, sir.
Yes. So here participants are faculty members from AICT institutions.
Okay, sir.
So
Okay, sir. Okay,
it
sir.
is
Okay.
I think important for them to get to know that we have such a nice and wonderful opportunity to, let's say, work with Abhijeet sir, and you can interact later. You can note down your his contact details.
So these are the ones, sir.
Okay, so let's thank
Thank
you
you, sir.
once again,
Thank
sir.
you, sir.
And
Sir, it is
we
an
are
honor. It is really an honor to talk to in a faculty development program. I am really so honored, sir, to have an interaction with you. Thank you very much, sir, for giving me an opportunity. And should there be any more interaction, I am always open, sir. Thank you very much, sir.
it's our privilege to have you in this session. Thank you. Thank you so much.
Thank you, sir. Thank you, sir.
Okay, so you may leave, sir. We'll contact you later.